Temperature. And I believe the reason why we throw temperature in today is not really to give you a lesson on what temperature is, but temperature is one of the few places that we see not only what we call positive numbers, but also some negative numbers. Let's take a look. Let's just draw a little thing here. I don't know why we draw thermometers like this anymore, because we're not allowed to have mercury and stuff that makes these thermometers like this, but we will anyway. Usually our thermometers, if you're not in the metric system, let me see if they talk about metric here, do they? If we're not using centigrade, I guess they do a little bit. Let's do two of them here. We have the Fahrenheit scale, which we'll just abbreviate as the letter F. And our standards are, people decided back when they were finding and marking up degrees of temperatures, they said, well, a good place, a good consistent thing is 32 degrees here Fahrenheit, because what happens at 32 degrees?
Water freezes.
Yeah, water freezes. And that went all the way up to 212 degrees because that's where water boils. And anybody can freeze water and boil water, so you kind of have that thing that you can set all the time. Well, the smart people in the metric system, the centigrade scale, or Celsius if you will, they were pretty wise in the fact that they said, I don't know why you'd use 32 and 212. The more logical temperatures to use for water freezing would be 0 degrees. And where it boils, make it 100 degrees. 100 degrees. Now, if temperature goes up only 1 degree, is that more of a change in the Celsius world or more of a change in, if the temperature went up from, 20 to 21 degrees in Celsius, or if it went up from 20 to 21 degrees in Fahrenheit, in which scale would the temperature go up more if it went up a degree? Amelia?
Celsius?
Yeah, because there's fewer markings here, each degree means a lot more. So the more, each degree gives you a bigger rate of change there. But what we're really talking about today is not just the positive numbers, but a lot of time the temperature goes below the freezing point of water. Okay, and that's where we get the negative numbers here. Maybe you get minus 10 degrees. You come down and maybe get minus 20 degrees. Some of the colder temperatures, especially here, I don't know what minus 20 degrees is in Celsius or whatever, or Fahrenheit here, but, we call it 15 or whatever degrees below 0. That's a pretty cold day out there. Okay, but the problem comes in this. Here's a question you're going to need to answer here. If the temperature went from 18 degrees to minus 6 degrees, how much did it drop? The temperature started at 18 degrees and went to 6 degrees below 0. How much of a temperature change is that? Well, and if you draw this out just a little bit, with our first working here, it went from 18 degrees, it dropped past 0 degrees, and then it went to 6 degrees below 0. How much of a change is that? And here's where negative numbers get a little confusing for us, because in order to figure this out, we know it's 18 degrees to get from 18 to 0, right? And then how many degrees is it to get from 0 to minus 6? 6. So that's a total change of 24 degrees. The temperature went down 24 degrees, which doesn't seem logical to us because neither one of these numbers is close to 24. And I really have to add them together, 18 plus 6, to actually get the change. So you have to start thinking a little bit in positives and negatives sort of things when they talk about, especially when you see these temperature things, it'd be wise for you to draw a little thermometer kind of thing there to do it there. And they do ask you some questions about doing things like that. For example, look at page 640 in your books. Just looking at the sample, the lesson practice part there, letter A says, use digits and symbols to write the temperature that is 12 degrees below zero on the Fahrenheit scale. How would you write 12 degrees below zero, Bryce?
-12 degrees.
Right, make sure you put the little circle there for the degrees, okay, below zero. And then you'd have to put the letter F because there's a big difference between 12 degrees below Fahrenheit and 12 degrees below Celsius. Which one would be colder?
Celsius.
Yeah, by far. Actually, they both even out at what temperature? Does anybody know? You can take a guess.
62.
Nope, 62 degrees Fahrenheit is like medium warm. 62 degrees Celsius is like 150 degrees or something like that. They meet out in the below zero, by the way. They actually are the same at one temperature. Celsius and Fahrenheit are the same, and then they just keep getting farther and farther and farther. You all know this. Jack, we'll take a shot.
-degrees.
Minus how many degrees?
42.
You're close. It's actually 40 degrees below zero. At minus 40, Celsius and Fahrenheit are the exact same, and then they keep getting farther and farther apart as they go up there. Look at practice B there. What is the temperature shown on that little thermometer? And again, here's where you got to watch. Okay, is your number going to be above zero, below zero? Is it below zero, above zero? Take a look there. Grant it is.
-5 degrees Celsius.
Right, -5 degrees Celsius. Letter C, is the temperature shown on the thermometer, if the temperature shown on the thermometer is 14 degrees lower than the high temperature for the day, then what was the high temperature of the day? 14 degrees lower than the high temperature of the day. Again, that's where if you have sketch this out, the temperature on the thermometer was, what, 5 degrees below zero, right?
Yeah. And if you go 14.
And that was 14 degrees lower, so you need to go up 14 degrees from there. Well, to go from 5 below to 0, that's 5 degrees. How many more degrees do you have to go up?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. So, how many degrees would it be?
19 Celsius.
9 degrees. It went up 9 degrees Celsius, yes. Letter D, if the temperature falls 3 more degrees from the temperature shown there, if it's here and it goes 3 more degrees down, what temperature would that be? Bryce?
-8 degrees Celsius.
-8 degrees Celsius. And again, I'll help by pictures there. And the rest of that you can kind of figure out for yourself.